Hello everyone and welcome to our webinar. A very special webinar because it's the launch of our newest and most powerful sensor in the ATOS product family. Made by ZEISS and made in Germany, it's a specialist for 3D scanning of large volume parts. It's a new ZEISS ATOS LRX. My name is Andreas Angermeier. I'm sales engineer at ZEISS Industrial Quality Solutions. I studied casting technology and have been working with optical 3D measuring systems for over 10 years now. Today I have the special pleasure of introducing you to the ZEISS ATOS LRX. Our new ZEISS ATOS LRX is a specialist for fast digitizing of very large geometries and free-form surfaces. This is exactly why it is perfectly suited for applications in the field of casting, shipbuilding, aerospace, automotive, or even power generation. We are thus entering new territory and closing a gap in our portfolio that has not been able to be met up to now, neither by laser scanners, conventional fringe projection scanners, or laser radar systems. With our new ZEISS ATOS LRX, it is for the first time now possible to cover applications in which very large measuring areas have to be captured with high metrological precision. And this involves accuracies of a few hundredths of a millimeter. As you will see, we worked with various partners from different industries. But before we take a look at the system in action, I want to briefly introduce you to the technical features of this new sensor. The new ZEISS ATOS LRX is the specialist for fast digitizing of very large surfaces. Its technology is based on data collection by means of stripe light scanner. Thus, it is equipped with two 12-megapixel cameras and a very powerful projector that contains a newly developed extremely powerful light source. With this, it is possible to precisely generate full-field data within a short time, and this is the first time for measurement areas of up to 4 square meters. With a single scan, ZEISS ATOS LRX captures up to 12 million independent measurement points and 3D coordinates. This corresponds to a grid of 0.5 millimeters. This allows a complete 3D model of a complete component to be scanned and analyzed in a remarkably short time, including the free-form surfaces and the geometry elements. This can only be achieved with an optimal exposure. We have accordingly developed an innovative lighting concept with an ultra-bright laser light source. With the ZEISS ATOS LRX, it is possible to capture technical surfaces under normal light conditions, and these can be dark or shiny. Despite the laser light, ZEISS ATOS LRX still offers maximum safety in manual use. A sensor permanently monitors the safety zone to the user via radar and, if necessary, reduces the light intensity. This classifies the laser light source in the non-critical laser protection class 2 and allows the sensor to be operated without further protective measures and the need of a laser protection officer. Furthermore, the assignment to laser protection class 2 permits the use of interactive features such as probe measurements or back projection. The housing of the sensor is especially designed for industrial environments and is therefore dust-proof and protected against splash water. In order to be able to work reliably and precisely even in harsh environments, the system self-monitors its calibration status. Let's now take a look at the sensor itself. The ATOS LRX is delivered with a sensor head, the stand, and a computer. The ZEISS ATOS LRX is controlled directly from the corresponding GOM Inspect Pro software, which is part of the ZEISS quality suite. Let's see what a typical workflow of a component analysis in casting looks like. First of all, we start the GOM Inspect Pro software from the ZEISS quality suite. GOM Inspect Pro provides the entire methodological workflow in one package, starting from data acquisition, inspection, to reporting. To scan a new part, we first start a new project and initialize the sensor. By selecting the appropriate scanning template in GOM Inspect Pro, the corresponding parameters are automatically set and applied. In our case, we use the casting template. In the live image of the sensor cameras, we are now able to see the part to be scanned. We start with the initial scan. The scanned surface is immediately displayed in the preview in the software. To capture the part completely step by step, we simply reposition the sensor and start the next scan. We repeat this several times until the surface we are measuring is fully captured. The individual scans are automatically merged by means of reference points and overlapping areas. It becomes clear that due to the very short exposure times in combination with an extra large measuring field, significantly fewer individual scans are required for the overall measurement than with other systems. The ZEISS ATOS LRX is consequently perfectly suited for fast scanning of very large volume objects. Once the part has been completely digitized, the scan is finished. All data points are now polygonized to form a full surface mesh. This provides the basis for the software for all further inspections and analysis, as well as reverse engineering and simulation tests. In our example, the component has been scanned from only one side. In principle, all workpieces can also be scanned 100%. That means from all sides. In the software, a complete digital twin of the measured item is generated in this virtual way. A closer look at the generated data shows us how completely and exact detailed the ZEISS ATOS LRX has scanned the surface. This means that for the first time, a fast digitization of very large surfaces with metrological requirements is available. We are talking here about precisions of a few hundredths of a millimeter, with a measurement area of 4 square meters per scan. Now we move on with the analysis of the scanned part. For this, we switch in the corresponding workspace in the software. We see it all runs under the same user interface in GOM Inspect Pro. The user only has to learn one software, and this is intuitive and easy to use. Using drag and drop, we are now importing the CAD file into the software. If available, a measurement plan with the corresponding inspection elements can also be imported at this point. In the next step, the measurement data is aligned to the cut using an area of best fit. Subsequently, further alignments can be generated, for example via RPS or geometry elements. We get a quick initial evaluation of the measured part with a surface comparison. For this purpose, the polygon mesh is compared to the cut specification and the deviation are displayed in color. By setting flags, striking or interesting areas can be marked. Our example is the allowance check. The aim is to check whether the measured part has enough material in the surfaces to be machined later compared to its finished cut part. In addition, we also can inspect our component extensively for dimensional accuracy in terms of GD&T. After the analysis, the result can be displayed on report pages and compiled into a measurement report, if required. This can be archived as PDF. Furthermore, the results can also be used and made available for statistical evaluations and documentation. You have now seen a typical workflow of a new metrological project. However, we would like to show you some more practical functionalities. Depending on the geometry, it can happen that important areas of the measured object are difficult to detect optically or are simply not accessible at all. In order to be able to provide measured data here as well, the ATOS LRX enables the use of an optical tracked probe. This is calibrated by the system and can now, simply guided by hand, pick up individual measuring points or geometry elements such as cylinders or planes. This function is a very helpful add-on, especially if you, for example, want to measure deep holes. Another very useful feature is the so-called back projection. The sensor is able to project individual elements such as points or lines onto the surface of the part. These markings can be transferred onto the surface of the scanned object using an adding pen or center punch. A common application for this is, for example, marking castings. As the last new feature of the ZEISS ATOS LRX, I would like to introduce you to the fast recalibration, the so-called hyperscale. This functionality pays off especially in harsh industrial environments, for which the ZEISS ATOS LRX was especially designed. In other words, should the sensor detect a decalibration due to temperature changes, the system can be recalibrated very quick with the new hyperscale feature. Therefore, the sensor is aligned to the calibration cross and recalibrated within a few seconds with a single shot. This new feature avoids longer interruptions in the process. We have now presented you with a sound overview of the functionalities and performances of the new ZEISS ATOS LRX. And now let's hear from our customer, the Simpelkamp Gießerei, who is one of the first users of the new ZEISS ATOS LRX.
Ja, wir sind hier bei der Simpelkamp Gießerei in Krefeld. Eine echte Handformgießerei für Gusseisen mit Kugelgraphit, die seit 1983 ihre Weltrekorde aufstellt und heute als die Gießerei für schwerste und größte Bauteile aus Gusseisen mit Kugelgraphit weltweit gilt. Unser aktueller Weltrekord liegt bei 320 Tonnen für ein einzelnes Bauteil oder in den Längenabmaßen bei 23,5 Metern. Wenn man so große Bauteile exakt herstellen möchte, dann müssen auch die Details stimmen.
Unser Ziel ist es, einen Großteil eigentlich unserer Produktion zu vermessen. Das heißt, angefangen von kleineren Bauteilen, die kleine Abmessungen haben und nur geringe Tonnage, bis zu den wirklich großen Bauteilen mit sehr großen Dimensionen, wie eben das Zylinderkurbelgehäuse, was man hinter mir sieht. Der ZEISS ATOS LRX ermöglicht uns durch sein großes Messfeld, seine große Eindringtiefe und seine schnellen Reaktionszeiten effizient unsere Bauteile zu vermessen und dabei auch noch hochpräzise über dem normalen Standard, den wir früher etabliert hatten, durch manuelle Messungen, Messdaten zu generieren. Dadurch gab es eine hervorragende Symbiose aus den Anforderungen, die wir hatten und dem, was die Firma ZEISS liefern konnte. Also alle Vorteile vereint, die unsere beiden Firmen eigentlich auszeichnen. Dass wir die Chance hatten, ein Messsystem wie dieses hier, eine Messzelle, eine Projektmesszelle zu etablieren, wie wir sie jetzt hier sehen und mit einer der modernsten Anlagen, die es im Moment auf dem Markt gibt, arbeiten zu können, das ist für Simpelkamp und auch für mich persönlich ein großer Gewinn.
Many thanks to Krefeld and the Simpelkamp team. As you can clearly see, the ZEISS ATOS LRX not only perfectly serves to scan extra large parts, but also offers a significant advantage in terms of data quality, speed, and precision. For the first time, it is possible to digitize very large areas and volumes of objects with high metrological requirements. This means very large objects, such as very large castings, ship propellers or models, mold halves or casted blanks in toolmaking, as well as mechanical engineering parts, can be metrologically recorded at speed and in high degree of accuracy. Structural components such as fuselage and wings are also of interest in aerospace engineering. Lee, my colleague, our expert for the aerospace sector, will tell you more about it.
I'm excited for the new addition to our portfolio, the Atos LRX. In aerospace, we have very large objects, fuselage, wings, where the Atos LRX, with its very short measurement time, will really enhance what we can do with 3D data to support the needs of the aerospace industry. I expect to see the sensor used in manufacturing and assembly of aerospace components, both in a manual and in an automated way. In particular, I feel the fuselage, especially in its green state, looking for the shape, profile, form, and especially defects prior to paint, which can be really costly to rectify. You can really get ahead of the game and make sure that these are measured and detected and rectified before the expensive paint operations. The size of the measurement area makes light work of really large objects because you're covering so much within one measurement position.
Thank you, Lee. The applications go further, from capturing wind turbine rotor blades, digitizing clay models in automotive design, to quality control of large welded assemblies in mechanical engineering. With the help of full-field 3D scans, the ZEISS ATOS LRX now allows fast and comprehensive digital processes and quality control for the very first time, even for extremely large parts. Defects and imperfections on parts and tools can be quickly detected, corrective measures can be initiated at an early stage, and processes can be continuously optimized. The ZEISS ATOS LRX is thus the perfect partner for data-based quality assurance and control. Thank you in advance for your interest in our new ZEISS ATOS LRX sensor. We are looking forward to chat with you right now in the live Q&A. To ask your questions, please use the chat function. Contact us for your individual demo session at your site. Thank you very much.